This video is on inverse functions graphically. So again, we do not have to have the equation to determine information about the inverse. If we have the graph, we can determine if the inverse is going to be a function, and we can also determine what the domain and range of our inverse is going to be. So for these examples, we're going to be given the graph, the actual graph of them, and we're going to determine. So we're going to answer the questions for each graph and graph the inverse on the same coordinate grid. So we will be graphing the inverse on here. We're going to be using interval notation for domain and range because we have the graph. If it was just coordinates, we would be using set notation. So again, we need to understand what an inverse does to our coordinates. It just flips the x's and y's. So a good thing to do would be to figure out what the coordinates are, so we can easily graph the inverse coordinates. We're going to determine if what the original domain and range are. We're going to determine what the inverse domain and range are. And then we're going to determine if the inverse is a function. But we have to give two reasons why it is or why it is not a function. This first example, I'm just going to write out the coordinates that I can easily tell in order, so I can graph the new graph, the inverse, without having much difficulty. So the original, I'm going to write out the coordinates down here. So one coordinate is at -2, 3. Another coordinate is at -1, 0. Then we have 0, -1, 1, 1. 1, 0. Then we have 2, 3. And I believe that's going to be enough coordinates. The domain of this graph, if we remember, goes back to the farthest left and the farthest right. The domain of this graph will go to -infinity and to +infinity. The range of this graph starts with your lowest y value to your highest y value. Your lowest y value is at -1, and your highest y value is that arrow, so that's that +infinity. So it's going to start at that -1, and it'll go to that +infinity. Now, before I even graph this, I can automatically know what my domain and range will be for my inverse. So without graphing it, my domain of my inverse is going to be the same as my range from the original. So my domain will be from -1 to +infinity. Close bracket on -1, open on the +infinity. My range for my inverse will be the domain from the original. So it'll be -infinity to +infinity. I can also determine right now if the inverse is a function. If I look at this graph and I do the vertical line test, that'll tell me if this graph right now, that's graphed right now, is a function. The vertical line test, it will pass. So this one is in fact a function. The original is a function. But I want to determine if the inverse is a function. So I will do the inverse of the vertical line test, which is the horizontal line test. So if I were to draw horizontal lines on here, it would not pass it. That doesn't tell me anything about this graph right now. It tells me about the inverse's graph. The inverse's graph would not be a function. So is the inverse a function? The answer is no. There are two reasons. One reason is that the original graph fails the horizontal line test, or the HLT. There will be another reason. Once we graph the inverse, we'll then be able to check, since we have it graphed, we will have it graphed, we will be able to check the vertical line test. Once we have it graphed, we can check the vertical line test. So let's find the inverse coordinates so we can graph this. We go back to the original coordinates and we're going to flip them. So we're going to have 3, -2, 0, -1, -1, 0, 0, 1, and 3, 2. Because all it is just flipping the x's and y's. So to graph this on here, I'm going to have my x and y on my axes. I'm going to graph these coordinates. So 3, -2, 0, -1, -1, 0, 0, +1, and then 3, +2. And we know that it should go from -1 to +infinity. So I don't have anything to the left of -1. And I know that this will go down forever and up forever because of the range, the new range. So connecting these points, this is the inverse of that original quadratic. And we can see that the left value is -1, and it goes to the right forever. So -1 to +infinity. It goes down for the range, and it goes up for the range, so -infinity to +infinity. We still can say that this is not a function because now that we have this graphed, we can check the vertical line test because we have the graph. So this red one, if I drew a vertical line, it would not pass. So the other reason why it is not a function is the inverse, the actual graph of the inverse, fails the vertical line test. Now to show you the reflection, the fact that this is a reflection over the line y equals x, if I were to graph the line y equals x, I'm just going to graph this lightly just to show you. These two coordinates, if I were to make this vertical, these two coordinates right here are inverses of each other. If I connect those, the line of reflection that y equals x is going through the middle. If I did the same thing with these two coordinates, because they're inverses, these two are inverses, this one way over here, and all the way to there. All of those lines are being cut in half by this y equals x. That's how we know that this is a true inverse. I'm just showing you that y equals x. That's how you know that you have graphed the inverse correctly. On this next example, we're going to find the domain and range real quick of the original. The domain is going left forever and right forever, so it is -infinity to +infinity. The range is going down forever and up forever, so it is also -infinity to +infinity. Therefore, the inverse's domain is going to be the original range, so it'll be -infinity to +infinity. And the inverse's range is the original domain, so this will also be -infinity to +infinity. Is the inverse a function? We can determine that now. So again, the graph that we have, the vertical line test will determine if the graph is a function. I want to know about the inverse, so I do the horizontal line test. The horizontal line test. Now it looks like it would cross twice here, but what's happening is it is curving on it. It's curving, but it's passing through. So that's not a horizontal line there. It would still pass the horizontal line test here. This would also pass the horizontal line test. So the inverse is a function. And again, one of the reasons is because the original graph, the original, passes the horizontal line test. That lets you know if the inverse is a function. So to write some coordinates down so we can graph this, one coordinate on here looks to be at -1, -1. Then we have 0, 0. And then we have +1, -1. So to graph the coordinates of the inverse, I'm going to flip them. So we're going to have -1, -1. Then we're going to have 0, 0. Then we're going to have positive 1, negative 1. I'm sorry, this was negative 1, positive 1. Let me change that. This is negative 1, positive 1 in blue. Therefore, on this one should be positive 1, negative 1. I apologize for that. And then this last one was 1, negative 1. So this coordinate, when I flip it, will be a negative 1, positive 1. So I had the coordinates wrong on there. I apologize. So the coordinates are now positive 1, negative 1. So 1, negative 1. Same coordinate we've had before. 0, 0. And then negative 1, positive 1. So these are the same coordinates. But if we remember, it has to cross that y equals x. The inverse of this is going to be, this is a cubic. The inverse is a cube root. So when we connect these, it will actually go in the opposite direction. So instead of it curving down, it'll curve around. Then it'll curve this way, because they have to inverse each other. So this graph will have more of a, this one's kind of going down, so this one will go left. This one is going up, so this one will go towards the right. This is the inverse. It is curving, almost like an S here, just like the original one did, but just going in opposite directions. So now the other reason why this is a function, the inverse is a function, if we look at the red, if I were to draw vertical lines on the red, it would pass the vertical line test. So the inverse is the red graph. The inverse passes the vertical line test. So it's a function. This example over here, we have a line. The domain of the line is negative infinity to positive infinity. And the range is also negative infinity to positive infinity. So the inverse domain is the original inverse, so it will be negative infinity to positive infinity. The inverse range is the original domain, so it will be also negative infinity to positive infinity. Is the inverse a function? So again, we can look at the original right now and check the horizontal line test. So horizontally, it would only cross once. So that means that the inverse is a function. Again, one of the reasons is the original passes the horizontal line test. That means that when we graph the inverse, it should pass the vertical line test. So let's get some coordinates to graph. So for the original one, we have this coordinate of negative 4, positive 5. Then we have negative 2, positive 4. Then we have 0, 3. 2, 2. 4, 1. For the inverse coordinates, we will have 5, negative 4, 4, negative 2, 3, 0, 2, 2, and then 1, 4. X and Y on the axis. All right, 5, negative 4, negative, 4, negative 2, 4, negative 2, 3, 0, 2, 2, 1, 4. This does have a domain of negative infinity to positive infinity, and it has a range of negative infinity to positive infinity. This red graph would also pass the vertical line test. So the inverse passes the vertical line test. That's also why it's a function, that the red is a function. And just to remind, it is an inverse if it does reflect over the line y equals x. So if I were to have these coordinates and I were to connect the coordinates with its inverse, it would cross over and it would intersect that y equals x, and it would be crossing through them almost directly in the middle. So cross through them directly in the middle. That's how you know that it is in fact an inverse, because it reflects over that line y equals x.